Good afternoon, everyone from Waldorf for me today, normally Dublin. What I want to talk to you a bit about today is, as Alina mentioned, my focus has always really been about embedding predictive capabilities or machine learning capabilities back into SAP applications. And we've been working on this topic for some time now. We work with a lot of different teams across SAP, including S4HANA, Cloud for Customer, Hybris, SuccessFactors. But really one of the very first applications we worked with was SAP Fraud Management. And we started the work with them sometime last year. And by coming together, I think we came up with a really interesting way to use predictive capabilities in SAP Fraud Management. And I think fraud management were really key. They're such domain experts to really understand what their users were looking for and to make sure that we could not only make these predictive capabilities available to fraud management customers, but do it in an environment that felt very comfortable to them as well. So I'm actually really excited to take you through this particular presentation today. Okay, so in terms of the agenda, we're just going to give a really quick overview about machine learning and predictive analytics. We're going to talk a little bit about the Business Objects Predictive Analytics Suite and how that kind of comes together across all the SAP products. We're then going to introduce you to Pi, or the Predictive Analytics Integrator. But I'm not going to spend too much time on this. I really want to get straight into the demonstration. So let's get to it straight away. So first of all, when we talk about predictive analytics and machine learning, what are we actually talking about? So I think analytics has been a big part of most SAP applications for some time now, and the ability for key users to be able to drill through that data, visualize it, come up with insights, I think has been really important. And most of SAP tools do this really well today. But we know that the world of analytics is changing, and really people are wanting to be more forward-looking and even start to try and predict what's going to happen in the future. So really what we're saying here is if we could use machine learning techniques to complement the insights we know that our domain experts have, but maybe identify insights that they may not see with the naked eye and come up with maybe new insights that maybe they didn't see. And to do that, we want to use machine learning and predictive analytics. So at SAP, we already have quite a few, we have a predictive analytics suite, which comes together with a number of different products. Everything from how you prepare your data with Data Manager, to how you create simple and easy to use models using Automated Modeler, to producing somewhat more complex models using Predictive Composer, and then into tools like Factory that help us manage the life cycle of that. So we already had some really good information and really good tools that could be used, but what we really wanted to do was deeply embed these back into our applications. So as I mentioned, we were working with teams such as Hybris, Fraud Management, and the reason I'm here this week, S4HANA as well. And to do that, we kind of tried to think about what was the best way of going about it. So the first thing to mention is, at SAP, one of the big things we've been focusing on is the digital core. And what do we mean by that? So, for example, majority of our applications now sit on HANA. And HANA is a little bit special. I think people think about it sometimes as just an in-memory database, but it's so much more than that. We know that within HANA, it's like a platform. We have a predictive engine, and we also have access to a number of predictive libraries that sit directly within the application. So a lot of times when you are talking about, using business applications with predictive analytics, there often is a process of extracting that data, manipulating it, working with it in a tool outside of the application, and then when we're finished, trying to write scores back into the application itself. And this can often be quite time-consuming, but also can delay how we can get that insight back to the business user. So knowing we had this unique opportunity in SAP, we came up with a new product as part of the overall SAP Business Objects Predictive Analytics Suite. And we called it the Predictive Analytics Integrator, or Pi for short. And basically, Predictive Analytics Integrator does what it says in the tin. It helps us integrate predictive directly into that digital core. So what does it mean for us? Well, at SAP, it means that we can start to enable, particular teams like S4HANA or Fraud Management to integrate predictive use cases directly into their business application. But also going forward, what it means is we can enable our customers and our partners to use our predictive analytics tool to build out either more complex models or even just different use cases and, ingrain those directly within their business application without any coding, without any huge development cycles, and also safely. It's important that we maintain the integrity of these systems that we're working with. So with Pi, we're not only making it easy for you to get models in, we're also protecting, the digital core and all of that, important data that's important to our business users. Just talking a little bit more about what Pi is. So we are deeply embedded within, the SAP framework. We are able to use, for example, the NetWeaver stack, to manage these ABAP objects at those levels. The scores and any of the insights that we produce can be consumed directly by the business user or the decision maker. There is no intermediary step where it needs to be published to them. The life cycle of the model can actually be maintained directly in the application. So, for example, if over time my records may change, I can retrain that on fresher data directly in the application. I don't have to call a data scientist and I don't have to call somebody from IT. I can simply do that directly in the application. And I'll show you exactly how we do that in fraud a little bit later. Again, by doing this, we are avoiding these lengthy development cycles, and this is so important. If we are looking for future-looking events and future forecasts, waiting weeks or even months to get these insights into an application just simply isn't acceptable. We need to be able to do this very, very quickly in order to really gain the benefit of these insights. And then finally, the really important part is, yes, at SAP we have many, many ideas of machine learning use cases and predictive use cases that we wish to ship for you. But we know already our customers are telling us that they have their own use cases that they want to use, or that they have maybe tweaked a business process within SAP and want to maybe just adjust the model that we have shipped as part of the process. And what we're working on very, very hard this year is to enable that using the SAP Business Objects Predictive Analytics tool. Okay, so fraud management. So SAP Fraud Management has been around for some time. It's not a brand new application, and it's been very, very successful identifying and helping to prevent fraud. And what it's been doing over time is it uses historical data where an analyst has looked into the data, and it's actually used these HANA rules framework to try and detect what is likely to be fraud or not fraud. In general, these type of rules framework comes from the domain experts or the fraud analysts. So these are people who have really deep knowledge of, fraud in their different areas. And so what we wanted to do was not change this. This is also a really good process. We know these fraud analysts have really deep knowledge in their areas, but we want to complement it by addressing maybe identifying fraud using predictive algorithms. So using the historical data that we have, using claims or maybe objects where we've already identified whether something was fraudulent or not fraudulent, and using these particular documents against a predictive algorithm to try and identify new fraud cases. By doing this, what we've actually seen is we've been able to increase the accuracy, and also by doing that we mean we're reducing things like false positives where maybe our fraud analysts spent a long time investigating particular objects which were not fraudulent, but also reduce the risk of missing out on cases, so false negatives, so where something was a fraud, but potentially it was a new type of fraud and therefore we missed it. So again, these historical, the rules framework isn't going anywhere. We continue to use that, but we're just complementing it with a new type of way of identifying fraud. And like I mentioned, this is one of the first use cases that we had went live with Pi. And what we did was we shipped these particular use cases directly within the business application. And we created a new object directly within fraud called the predictive detection method. So again, as you can see here, we're really using the language of fraud. We're not trying to make it very data science-y and very, unapproachable. We're actually using language that a fraud analyst would understand. And this new method we have ingrained directly within the application itself. So what does it mean for the actual user? So what they can actually do is they can go in there, they can select the claim object, they can select which data they want to use, they can apply some parameters, and they can actually train a brand new predictive model directly in their environment without the help of a data scientist or someone from IT. And once they've done this, they can then look at some of the information behind that model to understand why it's picking certain items as fraud. And also, if they feel over time that the data is changing, they can trigger a retraining of that model directly within the application. So like I mentioned, this is live and available today. We released it in August of last year with SAP Fraud Management version 1.3 and SP2. So that is available for you to use today. I said Kevin's on the call. We can talk about licensing and all those things towards the end, but he's your go-to guy to go through any details you may have around that. Let's go straight into the tool. So for those of you who may not have seen fraud management before, this is the fraud management dashboard. So here we have all kinds of different tiles and tabs that can be used to manage the fraud within your organization. So as I mentioned before, what the area we focused on is identifying fraud, so detection. So if we jump to the detection section, previously we had this editor, which was the detection method editor, which allowed us to configure rules directly in the HANA rules framework. So like I said, this is still here and it's still a very powerful part of the fraud offering. But what we're doing in advance of that is we've added a new tile called Manage Predictive Detection Methods. So if I select that for you there now, I'll show you exactly what that looks like. So here we have a number of detection methods which have been created by various users on various different objects, from looking at bank customers to maybe claims, to accounting transactions, to travel expenses, you name it, whatever we've configured within the fraud management tool can be used as an object to identify for fraud. And to create a new one is actually really, really simple, and I'm just going to show you how we do that now. So we simply go to the Create tab. We need to give it a name, so we're going to call it Predict Fraud Demo. We need to give it a description, so I'm just going to give it the same description. We then need to pick the object. So again here, we're not asking data science-like questions like pick target variable. We're actually asking a question a fraud analyst would understand. So what is the object I'm looking to check the fraud on? So I select the drop-down. So these are all of the different use cases that are already available in fraud management today. And I'm just going to use claims as an example. And the next thing I can do is I can actually put in some selection parameters. So for example, maybe I want to only look at insurance claims for cars or insurance claims for home insurance claims. Or maybe I want to restrict it to a certain age group. So by going into the selection parameters, I can actually do that here. So if I take age as an example, I can say between. So maybe I want to look at auto claims for maybe young drivers. So someone between 16 and 25. I can select OK. The next thing I need to do is identify what data I want to use to train my model. So basically it's kind of asking me how far back do I want to go in terms of my historical claims to use to train this model. So let's go quite far back. Let's go back as far as 2010, the 1st of May. And we're going to finish that up with the 1st of May in 2017. So now I've selected quite a wide range for my training. In some cases I may only want to pick the last month or the last year, but again this is completely up to the fraud analyst to decide that. The next thing I need to do is identify where my training data set actually sits. So I need to pick that here. So one of the good things that fraud has done here is if I've picked claim as my detection object, it automatically limits the tables that I can use to do the training. So it doesn't mean that I'm not picking, for example, a bank customer object and then trying to train that on claims data. So it's already trying to protect the user from making some silly mistakes. It's limiting what they can do. So in this case, I'm going to pick the claims data data view. And also what I'm going to need is the historical decision view. So what is this? This basically means where somebody from the fraud team has already checked the claim and identified whether it is or it isn't fraud. So I need that for my model to learn on. So again, I'm going to pick that decision view. Finally, I need to identify an investigation reason. And again, this will help me with my alerts a bit later on. So again, I'm picking claim. Here's my claim object here. I select OK. And what I'm going to do next is I'm going to select Save. And what will happen here is in the background, Pi is going to pick up all of the parameters that I've just sent here. It's going to package them up. It's going to put them against a classification algorithm using the APL library, and it's going to create a model for me. But not only that, it will create a number of procedures that will enable me later to apply that model to fresh data so I can generate fraud alerts. So the first thing I do is click Save. Okay, so now it's been submitted for creation. So like I said, this is actually a training exercise, and this could take some time to run. So what I'm going to do is show you one that I've created earlier. Okay, so here's one I created just yesterday. And this is exactly the same as I've just shown you here. We see I had a filter in there showing me the age range. And I also see down here some information about the model that I've trained. So one of the things we mentioned is we want to keep this in the language of the analyst, so the fraud analyst, in terms of they want to be able to understand it within the context of identifying fraud. But they also want to have some confidence that the model that they've built actually is quite good. So we don't want to be making decisions based on bad models or if we had poor quality, what it would mean for the actual model itself. So the first thing you can see here is we have two objects called the predictive power and the predictive confidence. And the closer these are to 1, the better we believe they'd be. So in this case, we can see here we have quite good predictive power and predictive confidence. It also tells us the number of records that we've actually used to train the model. So in this case, we used a little under 1,500 records. It's also telling us within that sample how many of those records were actually fraudulent. So we can see that roughly about 5% of the records were actually fraudulent. Then we have over here is the day that we actually, the dates we selected to train the model, but also over here when it was created and when it was changed. But not only that, we can see the status of the model. So that you can see this one here is our active model, which is being used, and this is one that we previously used. So at any stage, we could actually select it and make it active, or at any stage, we can create a brand new model. We'll go to that in just a second. But like I mentioned, the fraud analyst wants to know a little bit more about why this particular algorithm is identifying particular objects as fraudulent or not fraudulent. So if we just scroll down a little bit, we show here what we have as the key influencers. And the key influencers basically tell us, after we train a model, what were the variables in my data set that had the most impact on whether an object was determined to be fraudulent or not. So as you can see here, the amount seems to be quite important, so whether it's the amount of the claim, whether an expert was involved in assessing the claim, the brand of car, by all accounts, seems to have had quite an impact, and also the number of policies the person held seems to have had an impact as well. So what we're doing here is not just giving the fraud analyst a blind result, we're actually showing them what the algorithm found. So maybe even at a later date, when the fraud analyst is setting up maybe new rules, it can start to use what it's learning from the machine learning and put that into the rules framework as well. So just scrolling a little bit further down, just some technical information here. So we do have an idea of the data that we selected. This is the data that had the different claims. This was the data set that had the decision that was made on those claims, and this was the training view that was created to combine those two objects. So again, all this is done for us in the back end. The fraud user doesn't have to worry about that. But then also down here, not only did Pi create the model, it created a number of procedures that can be applied to data in order to apply the model, to execute the model, but also bring back some additional information about that model. So again, no one in here has to do any coding. We didn't have to call IT and say, hey IT, we built this model, can you please wrap it in a procedure so that we can call it in a user interface? All of this has been done by Pi and by the fraud management team in the UI they've created. One more step we have here. So I mentioned again retraining. So this is really important. We know that fraudsters, they change their tactics over time. So it's important that we are able to keep up with them. And so what we have here is the ability to retrain this. And what we can just do here simply is select some new training data range and select retrain. And once I do that, it will kick off a new model version below, and it will start to train that model. And when it's completed, again, I will have a new model within my list here as well. Okay. So this is just showing you the detection methods. We haven't put this to work yet to generate new alerts. So I don't know if I want to pause at this stage. Kevin, do we have any main questions I can address, or do you want me to go on any further?
Well, there is one question about the data preparation, which might need your attention. So there was a comment earlier about some data is illegal to analyze. So the question is, how do you make sure that that data is not used in this analysis?
That's a very good question. So we work very closely with the fraud management team, and the fraud objects that you see here are the ones that they ship out of the box. I don't have exactly the answer in front of me here, but I understand that to ship this, they would have to make sure that those are objects that are legally allowed to be done. The customer can, of course, create custom objects, so that's not something we can control, but we know what we ship is, of course, legal.
Right. And then on the same subject, Andreas is asking about bringing in external data, ERP data, into this. So the fraud data would be data that was already brought in by the application, correct? So if they bring in additional data, they would have to maybe do it outside of the HANA runtime license since it's set up for fraud.
Yeah, potentially. I mean, we know that fraud do enable customers to create their own fraud objects. So long as the data resided, I think, within fraud itself, there shouldn't be an issue going through with that. But as you mentioned, if they're blending with external data, there probably would be something we would need to discuss with them.
Great. Thanks.
Okay, great. Okay, so from there, I'm just going to move on to what we do with this. So now we have our detection method. We looked up the, as I mentioned, the training results. We looked at we were happy with what we saw, and now what we're going to do is go and create a new detection method. So if I just go back out to the main screen, we had the detection method created. The next thing we want to create is a detection strategy. So if I select detection strategy here, we can see a number of ones that I already created, but we'll create a new one as well. Okay. So here you can see some of the ones that have been previously created, but I create a new one. So this is basically where we are kind of configuring the particular method that we've created to use it against fresh data. So we can create new, and again, we'll just give it a name, predict fraud demo. It again wants me to know what particular object I'm using. So again, we're using the claim. The investigation reason, so as we saw earlier, again, we're going to use the claim. If we want to add things like authorization groups or additional descriptions, we can do that. These are all optional fields. But what's important here is our threshold. So the threshold means at what point do we identify something as being fraudulent or not. So I'm going to set something really basic here, which is 50, which basically means that once it's over, for the classification algorithm, anything below 50 will be seen as non-fraudulent, anything above would be seen fraudulent. But I'll show you now how we can start to adjust those particular thresholds so that we can see how many fraud alerts that we are generating, and also make sure that we are generating ones that we believe are the most valuable ones that our fraud analysts should spend their time on.
And where do the options come from on the drop-down?
The options, these are directly coming from the fraud application itself. So these are the same objects that I used to create the detection method.
Okay, thanks.
Great. Okay, so again, for selection parameters, I'm going to do the same as I did in the detection method itself. So again, between 60 and 25. And then I'm going to go on to create my detection method. So I'm going to assign it. So let me just pick one here. Again, and there. Sorry. Okay, let's try claim. Okay, so sorry, I'm having a bit of a technical problem here. Okay. Okay, it's probably not connecting at the moment, but I do have one I've prepared earlier, which I can show you guys. Sorry about that. Okay, so if we go in here, this is one I actually created previously. Bear with me 1 second there. The demo got, okay, let's see now. Okay. Okay, so here's one I created earlier. So as you can see here, I have the threshold set. I have the selection parameters set. And I've also picked the fraud claim that I just created just a few minutes ago. Now, we can actually put another threshold in here as well. So again, you know, we put 50 on the base screen as basically saying to you, whether the classification algorithm identifies it as basically fraudulent or not. But if I want to make sure that I'm spending my time on, I suppose, the most useful claims, I'm going to set that to 86. So anything that hits an 86 or above, or 86% likelihood of being fraudulent, are the ones I want to focus on. But not only just that, I can actually see what that actually means. So I've saved the threshold as 86, but I can actually go in and calibrate that model as well. So just selecting calibrate, I'm just going to go into the calibration screen. Okay. And what we can see here, we just select the data range we want to calibrate on. So we'll go back to 2010, so we have a good source of data here. So you can see exactly the first threshold that I put here, which was the overall one that we're working off of, but also the score threshold, which is the percentage. So I have it down as 86. So if I start the simulation, and this is, remember, one I've actually used before, it will look and see, based on if I were to run a mass detection and create alerts right now, how many would it actually show me? So the first thing I can see is it actually wouldn't create any new alert items. So if I want to start creating new alert items, maybe I want to lower that threshold slightly. So let's lower it to, let's just say 75. And again, I can start a new simulation. So straight away it's telling me it's going to identify 3 new unclassified items that I need to work on. But maybe I'm thinking, look, I've got a bit more bandwidth than that. Let's go a bit lower. I can go, say, 65. Select Start Simulation. And now all of a sudden you can see I've got 67 new alert items. So depending on my workforce and maybe how many alerts I can actually get through, I can go through this and start to really play with the data before I do a mass creation of alerts. So if I can in fact handle 67 items because I have maybe 7 analysts who can handle 10 claims per week, and I'm happy with that, I can actually save that as my calibration. Save that there. And what I can do when I create the mass creation, it will detect 67 brand new alerts for me as well. Okay. So while it's doing that, I can start to show you what the alert screen looks like. So here we have our alert screen. So this is basically where your general fraud analyst would work. So they come in here and they can select the particular alert. They go through basically the different risk ratings that have been assigned to it. And they can go through the process of identifying whether or not this particular policy is fraudulent or not. So this is a bit of a kind of an empty item, but you see here it has a number of information about who the policyholder is, you know, what the information is about them, the amount of subclaims they have, and also sometimes the value of the different claims they have here. And they can also go through the different information screens here and, you know, identify what the likelihood of this is being fraud or not being fraud, and they mark that then back for other users to see as something that is or isn't fraudulent. Once that's done, we can actually change the alert lifecycle from in process to complete, and then this particular claim will now have a new ranking. So it will be marked as was fraud or wasn't fraud. And so in that case, when we're going to create any new detection methods further down the line, or even retrain existing ones, we can go ahead and say, okay, include this one in here. Based on the work that the fraud analyst has done, we have identified whether this is fraudulent or not. And based on that, they can go ahead and say, right, well, we can assign new roles and basically identify new fraud alerts through that. In a lot of cases, what we're seeing them do here is if they're finding new patterns, they are also updating the original detection methods and the HANA rules framework to make sure that they're not missed going forward as well. So basically, I think with all of these particular items, every screen you've seen here hasn't been something that was really data sciencey or something that maybe might have been difficult for a fraud analyst to understand. Everything we've integrated is within the cockpit of the fraud management system and is within their own environment. But behind the scenes, what we've done with Pi is we've taken the heavy lifting away. We've actually said, okay, well, we'll create the model. We'll identify what the best algorithm is for you to use. We'll also identify how to create procedures in order to apply the model, to calibrate the model, and also to retrain the model. So all of that heavy lifting has been taken away. And I think one of the most important factors here is we started working, I think, this time last year or even later with the fraud management team, and this was fully released to customer by August of last year. So the turnaround time for embedding these predictive capabilities is getting quicker and quicker because the teams that are embedding them just need to be understanding their domain. So, for example, we are also working with the S/4HANA team on finance use cases, procurement use cases, and also some logistic use cases. And in these cases, what we're really asking them is, where is your data sitting? Is it, do you know where it is? What is the business question that you want to ask? What is the kind of result that your users are expecting? And based on that, all they really need to do is potentially bring together the data sets, identify where they want to surface it and how they want to surface it. And largely with Pi, we're doing the rest. And I think that's pretty powerful. But as I said, moving on from this is really just our first step. This was the very first application that we worked with. We're working with a number of one. Procurement went live on Tuesday, so we have a lovely contract management use case there that is available for our S/4HANA cloud customers. And the big thing we're working on for the rest of this year is enabling our customers to adjust these. So you can use not only what SAP ship out of the box, but you can also use the predictive analytics tool to build either new models or more complex models and integrate them directly into these types of applications. And I suppose for a large part, this is where we're seeing the biggest value add as well. Okay. So from a high level, that's kind of what we're looking to show you guys today. Should we go back to some questions?
Well, the most recent one was what version of PA and what version of FM. I know it's 3.x, but what about the fraud management? What version of?
So the fraud management is 1.3 SP2, but it's in subsequent releases. It's available as well. And in terms of PA, we're using the APL, and that is version 3.0.
That's why I wanted to X. I figured I couldn't be wrong if I used an X.
Yeah. It's definitely the 3.0 version. Yeah.
Then there was other questions about how you changing the parameters, but I think I think you showed that though. If you wanted to change the parameters to get different results.
Yeah. So going back into the calibration screen, this was largely what we looked at here. So by just adjusting, sorry, let me minimize that. So by adjusting any of these values here, we can actually determine how many more claims or even the threshold here if we make this really low. In some cases, I think if you go down as far as, say, 60, we can start to see definitely more things coming through as well. So there we go, 109 new items based on the adjustment of those parameters, which I think is important because I think a lot of integration we see with predictive models potentially outside kind of Pi. Once it's embedded, there really is no ability for users to interact with the models to try and see what they want to get. And what we're seeing more and more is we understand that these people aren't necessarily data scientists that have the deep knowledge of maths and algorithms, but they know enough about what they're doing to be able to just adjust a few slight parameters or look at some of what the influencing factors are on a given model. And we think that's particularly important. I think we're moving away from seeing a predictive result and taking it completely on face value. We think most of our users and analysts are a bit more savvy than that and definitely want to be able to interact as directly with the model as possible. Okay. See now. Let's start with that one. So the underlying data still has to reside in the underlying HANA views. Yes, that's important. So the data needs to be available. HANA is probably the key component for Pi. If you're not on HANA, it's not something you can avail of at the moment. And yes, the data needs to be done. And actually one of the biggest topics that we find when working with any of our new teams is the provisioning or the creation of the new data sets. Normally is the most time-consuming part, identifying what the best data to use to bring together is, and once that's done, the rest of it seems relatively straightforward. So in any of the POCs that we've done with our own data scientists internally, I would say the first week is spent gathering together all of the data that's available and putting it in a view that can be used by a predictive algorithm. So that's normally the biggest step. So I have a question, but Pi is only supposed to be part of PA 3.2. So Pi is actually a separate component. It is part of the PA suite. So we do deploy that directly in applications. So Pi is shipped with fraud management and shipped with S4. Our goal is over the year to connect it with PA so that PA becomes the authoring tool and Pi is just managing the life cycle and surfacing of results. So it is part of the suite, but you don't have to, it's not necessarily that you have a specific version of PA that you need to use.
Well, since you answered that, I'll answer a related question, which is about the SUR. And in your SUR, it states that the application to interface with Pi, they must have PA Suite, because Pi and APL can't be interfaced by users without a license.
Yeah, sure.
How do you increase KI and KR?
So there's two ways really. So for KI and KR, what we often say the main way to increase these is either adding, wider data sets. So for example, if you're only using up maybe say 50 or 60 variables to train the model, if you can widen that data set with more information about the object, you can certainly increase the accuracy. To increase the confidence, if you use more records, so there's two things. One is widening the data set. The other topic is elongating it, and both of those should have an impact on your KI and your KR. And I think what's good to note in those cases is when you look at things like key influencers, you might see a lot of variables that aren't really having a bit of an impact. And actually what the APL algorithm is doing is identifying the best ones for you in that sense. But yeah, widening the data set or elongating the data set is the best way to increase those numbers. So yes, at the moment we don't enable the ability to tweak the models using predictive analytics, but it's something that we have planned for the end of this year. So it's a very big part of the overall vision for Pi, that we expect customers to use what SAP ships out of the box, and then they can use SAP predictive analytics to make either more complex models or even just use different models. So for example, at the moment we're using APL models, maybe there's a panel model that will give you a better result. So what we're doing is we're enabling the kind of understanding of predictive scenarios within Pi back into PA. And when you create your new model, you should be able to integrate that seamlessly back into the application. So that's one of the key vision that we actually have with Pi itself. And not only that, actually, one of the key topics for this year is not only if we ship a predictive use case with SAP that you can adopt it or change it. The other part would be we know customers maybe want to create their own use cases, in which case we want you to be able to go and use PA as your workbench, do some modeling exercises, go through maybe a number of different algorithms, and once you're satisfied, publish that back to the application as a new predictive scenario. And that's a very key use case that we're working on and one our customers are asking for. So that's a really good question, Andreas. So actually we've been doing quite a bit of work with a number of the different teams within SAP in the ERP space. And not only are we shipping these as standard use cases with SAP going forward, so procurement just went live, we'll be doing logistics later this year, followed by finance and sales. But what we're also going to do is we're going to start publishing the POCs that we're doing. So for example, if I look at the procurement use case, our data scientist combined the purchase order table, the vendor table, the payment terms table. He also derived 10 new variables, and he picked a specific algorithm against that and came up with a good result. So what we're going to do is publish these as blogs. So even if you're not quite on S4HANA yet, or you're not on, say, fraud management on HANA yet, there's no reason you can't take the logic that our data scientists have done on standard SAP data models and objects and use them in, if you're just a standard ERP, using the predictive analytics tool today. So as we are producing all of these standard POCs and shipping them with S4, we're also, and fraud as well, we are also going to make these available as blogs. So any customer can download data, even if they're just a standard R3 or ERP, they can bring that data as part of a flat file into PA and still generate the same results that we're getting from S4. Obviously, the deeper integration comes with the latest versions of SAP, but there's no reason those objects couldn't be used as well. And actually, you mentioned things like payment history. Yes, we have a specific one on invoice payment and a few other ones, which I will be showing you a bit later on. Okay. Can the models work on the data that's only in HANA virtually using STA, or does that data have to be persisted in HANA? Good question, Brian. We haven't tried that yet. I mean, Pi is fully integrated into HANA, so long as Pi can get access to the data, there's no reason we shouldn't be able to do that, but it's not something we have tested or shipped as yet. Very good.
This is a very interactive discussion. This is good.
Yeah. BW for HANA, yes. To create HANA views, that's actually a very interesting use case. I think last week that came up as well. I know Andreas Forrester, if he's on the call, has a wonderful blog on how you can do that, step-by-step guide. If he's here, he might want to post that again, or I'll post it afterwards, which is good. And okay, against Hadoop. So again, we have some further webinars coming up where we have done a lot of work against things like Hadoop Spark. Not necessarily specifically in the use case of SAP applications, but definitely something we want to do going forward. But there's quite an extensive amount of work that we've also already done with Hadoop, in particular with Spark and Hive, with my colleague Pretty, and we can definitely get you some information on that. It's definitely something that our business applications are leveraging more and more of. So it is something we will need to take into account as we move forward with Pi when we talk about, the different temperature storage, in terms of hot, cold, etc. So that is definitely something that will be part of our roadmap, hopefully bringing those worlds together. Yep. Okay. Yeah. And probably one of the things just to mention today, I've talked a lot about Pi with ABAP, but we do have another flavor of Pi that can work on non-ABAP systems. So my colleague Rob McGrath works very closely with the Cloud for Customer, also kind of Ariba, potentially Concur. So all of those environments that sit on HANA and use HANA but maybe don't use ABAP. The underlying Pi will be exactly the same as what you see in ABAP. We've just made the connectors different on how to consume, things in the Java layer rather than the ABAP layer. But we continue to work on those in parallel so that whatever we build for Pi, so the integration with PA, can be used in both ABAP and non-ABAP systems. Andreas, no, we haven't tried Pi with Vora to access Hadoop clusters yet. It's definitely something we want to do in the future. Like I mentioned, the really key focus for us this year is connecting PA with Pi and making sure we can publish models from there, but that is something that's definitely down the road on our list to do as well. Is it possible to know the configuration about the PA models Pi is considering? In our first release, we are really focusing on the APL library, so the Automatic Predictive Library. So for fraud management, they are exclusively using APL classification. I don't know how much you know about APL, but APL actually is the library that we acquired through the KXEN acquisition. And what it's actually doing is it's going through a number of different types of classification algorithms and picking the best one. And that's why we've used these for a lot of the first use cases. The APL libraries are really, really powerful. They also are really good at managing data for people who maybe don't have that in-depth knowledge. We know over time that potentially there are situations where very specific classification algorithms may be needed, and that's what we're enabling through the PA integration. But for now, largely anything you see with Pi last year and this year will be largely APL. So our models will be considered when the integration to PA is complete. So the goal would be that you create any models using PAL or R in the PA tool, potentially using Predictive Composer. And once those are complete, we would publish them back into Pi to be used. Pi won't be we're not going to turn Pi into a complete data scientist workbench. We already have that in PA. Pi will just manage the life cycle and surface the records. PA will continue to be our authoring tool. Yes, Predictive Factory will be the mechanism that we will use to actually publish those models. So you will go in exactly the way you do today. You'll create a project. Within that project, you'll probably identify the business application that you're working with. And once you've finished your activity and your modeling, we're hoping to add, and this is coming this year or early next year, as I mentioned, to publish that model into the business application so long as Pi is installed. Yeah, so yeah, Andreas, Predictive Factory would still be the way to go. For now, hopefully late this year, early next year, we should be able to say that we also support it with Pi as well. Okay.
Great summary. I think everybody got a good understanding of how a fraud investigator could use this without being a data scientist. I also think it's probably important to mention maybe the feedback that we got from partners about how this helped to generate more rules and allow them to answer more RFPs, because they could I think go beyond. There's a dozen rules that come with the system. How many do you remember?
Yeah, I think it's somewhere along those lines. So I think as standard, they get probably a small number of rules out of the box, and then the users usually go ahead and create their own. And it's very easy to do. The rules framework is very easy to use. I suppose it's knowing the right rules to put in. And I think what we saw here, and again, just maybe going back to, if we can find this one here, looking at the particular things like looking at, the key influencers and what were the key things that were having an impact. These probably are hints that they could use to maybe create new rules as well.
Right. So the ability to create new rules and to strengthen the existing rules is probably the whole justification for clients that would want to add this to the existing fraud systems.
Exactly, yeah. Okay. So Brian, a very good question, and actually I'm here in Waldorf this week meeting with Manfred Preisendorfer and Gerhard, and we're discussing some of the future areas that we want to work on. I think the GRC is one of them. Tax apparently is a huge one. I think that's very much on their minds. Tax compliance and tax non-compliance, as the case may be, is definitely something they're looking at this point in time as well. So yeah, and certainly we've also had a lot of interest from, in particular, fraud partners like Targens, who are interested in even building their own content on top of this for banks and that type of thing as well. Yeah, actually, I didn't show you that. I have that as part of another one. I'm going to see if I can quickly pull that particular weighting factor up there. Apologies there, I'll be just really quick, I think. So there is a way to see, I just need to use some historical strategies, but I'll see if I can just pull you up exactly where it shows you the false positives versus the false negatives. Let's see here. Okay, I'll just minimize that for just a second. Okay, so here we have confirmed false positives. So this is where we have a data set where we have already done some work on in terms of, identifying some false positives and false negatives. And in here we can kind of go a bit further into looking what that looks like. So confirmed, so we can have a look here maybe at the false positives. and it starts to bring us down actually how many false positives we had and what the value of them was. In this case, we don't actually have any false negatives, so none that we missed, but we can actually just give you an idea of some of the claims that maybe weren't picked up by this particular algorithm. And then some of the confirmed ones we can see here as well. We can see the value of those as well. It doesn't sum them up or anything, but it gives you an idea of which ones are there. And then we have our unclassified ones where we haven't actually checked yet to see whether they are in fact fraudulent or not. So there is the ability to see that. I think there is a way of seeing the value. Yeah. So here we have the confirmed value was in the region of 750,000. False positives were in the region of 463, and the unclassified are here as well. So as we move through it, we can go back in historically and look and see how good or bad the model actually was. Based on that, we can start to tweak some different things here as well. You can tweak it. So if I go a bit further up here and go back into this value and say, for example, I decide, okay, well, maybe if I just adjust the threshold here, maybe I think if I can change this to like 1, I don't remember now. Okay, that's not done it for me. There is another way, maybe a bit lower. Okay, let me go really low. Okay, maybe I need to go higher. Sorry, excuse me while I do this. Okay, so here we have, if I had really changed the probability, if I really had changed the threshold to a much higher one, and saying that the fraud had to be of a very much higher probability, I would have missed 15 confirmed, I would have missed 12 false positives, and the 5 unclassified. So I've obviously put it really, really high there. If I had it maybe slightly lower, you can kind of get the idea there. You can start to see, based on the thresholds that you're setting, what kind of values you're getting as well. So I apologize, I haven't had this one completely prepared, but you get the idea that, by tweaking this, we're starting to see what would have been missed, what wouldn't have been missed. So it gives you a slight idea on that as well. Sorry, I haven't this use case fully prepared, but I think you get the idea that if you should tweak it, what values.
It's actually pretty cool.
Yeah. And then again, you can see the value of those below. So what would you have missed, and what was the value?
Sure. So if you're a fraud investigator, and if let's say that you had 1,000, and then you started adjusting that to figure out which, get it to a manageable level, that could be very effective.
It could, yeah. So yeah, I haven't the exact simulation set up here, but you get the kind of idea anyway. And basically, you can keep playing around in here until you get to a point that you're happy. And once you're happy, you can save this. And once you save it, then you go back in to the overall detection strategies, which were, sorry, just can I go back? And just do mass detection. So based on what you've calibrated, once you run this, it will then generate the alerts. So again, one of the things that you saw there as well is if you only had a certain number of fraud analysts available, you could set it to top 100 or top 50. And that way you know that the alerts being generated are the ones that are the most valuable or the most likely to yield results. But again, this is all, you don't need to know anything about data science to do this. Maybe just a little bit about the probability threshold, but other than that, the rest of it is pretty much in your own language. Thank you.